Uh, Good afternoon to everyone. I welcome you all for second class of Flight Dynamics AE 8501. In our previous class, we have discussed that awareness about our subject, why we are studied, and what are the topics we have, and basic outcomes and objectives also. So today we are entering into our subject. In our first unit, cruising flight performance. So it is fully depends on passenger aircraft, how we are control our vehicle. So today we are going to cover two topics in this unit. So first one will be forces and moments acting on a flight vehicle. In our flight, what are all the forces act on our flight and moments we are going to list out. And second derivation will be, it's an important one also, equation of motion of our rigid flight vehicle. During the rigid motion, how the forces acted and how we are going to find out. So that is the ultimate aim of these derivations. So next we are entering into our topic. So first one, so all of you having your notebook, so kindly note this one, forces and moment acting on a flight vehicle. So that is the first topic. So I am going to maximize this figure. So just to draw this one. Just to draw the airplane and position the CG, center of gravity. After that, we need to draw three axes in a positive direction from the CG towards to the nose of the aircraft, that is the axis capital X. So here we are having angular velocity, that is small p. Angular velocity, that is p, and linear velocity, that is small u. So after that, we need to draw the lateral axis. So that is from the CG towards to right hand side of our aircraft. So right side wing, we need to draw a one line. So that is perpendicular to the x-axis and z-axis also. So here this is capital Y, angular velocity, that is small q, and linear velocity, that is small p. And third axis from the center of gravity to the towards to downward direction. So that is the axis of capital Z. Here we are having angular velocity, that is small r, and linear velocity will be small w. Have you drawn this figure? Students, give a response. Have you drawn the diagram? Students, you can hear my voice? Confirm.
Yes, sir.
Okay, have you completed? Shall we move to next step? Okay, I'm going to next step. I hope you are all completed drawn this diagram. So first assumption, we are going to draw one airplane, and next we are going to position the center of gravity in the aircraft. After that, we need to draw the three axes based on right hand axis system. So capital X, that is towards to nose of the aircraft, and capital Y, that is perpendicular to X and Z axis, it is towards to the right hand side of the wing from the center of gravity, and Z axis, it's in a vertical downward direction from the center of gravity, so it's also perpendicular to both the axes, so that is capital Z. And next one, we need to give the notation. Angular velocity, that is small p in the x-axis, linear velocity, that is small u. For the y-axis, angular velocity, that is small q, linear velocity will be small v. For the z-axis, linear velocity will be w and angular velocity will be small r. So these are all the assumptions we are applied for this aircraft. So next we are going to list out, so what are all the forces and moments act on an aircraft from the diagram. So you need to copy this table. So first topic over, forces and moment act on a flight vehicle. So here first column we are list out axis. So what are the axes we are denote in the aircraft? X-axis, Y-axis and Z-axis. And second column will be force along with the axis. So in a x-axis we have one force, that is F suffix x. For a y-axis, F suffix y, and z-axis F suffix z. So we can easily list out the force along the axis. If the axis capital X, the force will be F suffix small x. For a y, F suffix y. For a z, F suffix z. So we are completed force. So next one, moment. So what are the moments act on a aircraft? So we can get it from the diagrams also. For a x-axis we have one moment, that is denoted as capital L. For a y we are using capital M. For a z, capital N. So moment is nothing but force multiply with the distance towards to the point, like a center of gravity. So that is the moment. So moment for a x-axis will be capital L, for a y-axis capital M, for a z-axis capital N. And next one, linear velocity, we are denoted in the diagram. For a x-axis will be a small u, for a y-axis will be a small v, for a z-axis will be a small w. So these are all the linear velocities indicated in the figure. And next one, angular displacement. So that is angle. So how much angle our aircraft will be deviated from the origin. From the x-axis, the aircraft will be takeoff or landing. So then only we can get the angle deviation. So that is a pi. For a y-axis, that is theta, and z we have used a notation psi. And next one, angular velocity, that is p q r. So angular velocity will be p q r. And next one, inertia forces act on a aircraft, that is I suffix x, I suffix y, I suffix z. Have you completed? So first step, you need to draw a aircraft and locate center of gravity and locate three axes: x towards to nose of the aircraft, y towards to the right hand side of the wing, and z towards to the downward direction from the center of gravity. Next, you need to notate angular velocity and linear velocity, pqr and uvw. And after that, we need to list out like a table. So first row, first one will be axis, second one force along about the axis, third one moment about the axis, fourth one will be a linear velocity, fifth one will be angular displacement, and sixth one angular velocity, and last one will be inertia force. So we need to list out for each axis. So you have any queries in this first topic, you may ask a question now. Otherwise, we will move to next concept. Anyone have a doubt? Anyone please give a response. Balamurali,
Sir,
you have any doubt?
sir, angular displacementல லாஸ்டா இருக்குல்ல சார், நேம் தெரியல சார்,
R.
ஒழுங்கா புரியல சார்.
R.
இல்ல
Small
சார்,
r.
ஆங்கிள் பக்கத்துல சார், லெஃப்ட் ரைட் சைடு.
Okay, like psi. Now you can see.
எஸ் சார்.
Okay, thank you. So now we have moved to next concept.